Boom. All right. So yeah, last year's paper from Bosley for the new syllabus. Okay. First one seems easy. Which of the following is equivalent to 3 root 2? You multiply top and bottom by root 2. The answer becomes 3 root 2 on 2. C. Which of the following is closest to 2 pi on 7? Again, if you want to convert from radians to degrees, we just change the pi to 180 degrees, so it becomes 2 times 180 on 7. I'll get my calculator out. 360 on 7 becomes about 51 degrees. See? Just stop me if there's any questions. Which of the following functions has a discontinuity? All right, so that means it's not continuous, so there's a pause. We know these ones are v's, so that's continuous. This is a parabola, continuous. We're tossing up between these two. This one here is continuous because the bottom does not have any x values. There's no x values that will make x squared plus 1 equal to 0. There are no x values that will make x squared plus 1 equal to 0. The reason why I say that is because if you look at the next one, at the bottom, if x equals to 0 in the bottom, this bit here, you're going to have something, doesn't matter what it is, over 0, which is undefined. And because you're going to get an undefined, that means that's discontinuous. So essentially, this comes from the hyperbola family, right? Because on x, hyperbola family, which are undefined. So just keep that in mind. See how I didn't look at the whole function itself? I didn't bother looking at that. The first two I did because they were simple. These, well, you know what the idea is. The idea is all about the denominator. Otherwise, everything else would work on the numerator. Okay. Any questions there?
Nope.
It is given that log A equals log B plus log C minus log D. Which of the following statements is true? Do not ever try to just go and read A, B, C, and D. Do what we've always done. So, what are you going to do with the right hand side? What's log B plus log C? What is this equal to? Come on. Anyone? Eden? Log B plus log C?
Log B times C.
Yeah, log B times C. And then, of course, if you know it's minus log D, what are you going to do with that at the same time? If you wanted to?
What?
Divide by D. So it looks something like that. And then what are you going to do to the logs?
Cancel.
Cancel them out. Answer is A equals BC on D. So don't really look at it like that. It'll just confuse you. Just do what you would normally do. Don't think it's a multiple choice, essentially. Just do it normally. The probability that it rains on Saturday is 1/3. The probability that it rains on Sunday is 2/5. What is the probability that it does not rain during the weekend? Well, the probability of it not raining on the weekend must be 2/3 on Saturday. It can't rain on Saturday. And it can't rain on Sunday. So times by 2/5, which looks like it's 4/15. Oh, that's wrong. Sorry, plus Saturday and Sunday. No, hold on. And is times. Hold on, let's read this again. Probability it rains on Saturday is 1/3. The probability it rains on Sunday is 2/5. But the probability it does not rain at all during the weekend. It does not rain on Saturday. That will be 2/3 of the time. Saturday. and it can't rain on Sunday. Boy and girl. What's the problem of having a boy and a girl? Having a boy and a girl. Boy and boy or a girl. Boy or a girl you plus, boy and the girl you multiply. So half times a half, which is a quarter, because you can have a girl and a boy. Alright, good. So it is definitely times. So 2/3 times 3/5. 6 on 15. Which, divide them both by 2. No, what? Divide them both by 3.
3.
Ugh. 2/5. There we go. All right. So like I said, yeah, the probability of it not raining on Saturday is 2/3. The probability of it not raining on Sunday is 3/5. For and we multiply, for or we plus. So like if I just did a basic case there, what's the chance of you having a boy or a girl? Well, that's a half plus a half because you're guaranteed to have either a boy or a girl. So that's 100% chance. Whereas if you said what's the probability of having a boy and a girl, well that becomes a half times a half. That becomes a quarter of a chance of having a boy and a girl because you could have had a boy and a girl, or a girl and a boy, or a girl and a girl, or a boy and a boy. So 1 out of 4 of having a boy and a girl. Whereas if you're having a boy or a girl, it's an or, you're 100%. You're either going to have a boy or a girl. If it's one child in this case. Okay, so ors are pluses, ands are times. So yeah, that's what I mean by it's year 9, year 10 probability. So that's your basic probabilities that you're meant to learn, which we're going to learn next term. But anyways, I thought why not? So that was simple, right? Number 6, what is the domain of this function? What is the domain of x on root x plus 5? Okay, what's the first thing you're going to look at? Again, for domain.
The x-intercepts.
Not necessarily intercepts, x, I guess, values altogether, not just the intercepts. So the x values, trying to see like where x is allowed and not allowed. So you know that the top, everything's allowed, right? There's no issues there. The bottom, not everything's allowed. So that's the one that's going to focus on your domain. You know if you've got square root of x plus 5, x must be bigger than or equal to -5. Because if it was like -6, you would have -6 plus 5, which gives you -1. You can't square root -1. So you already know just for the fact that it's square root, the inside must be positive. So therefore x must be greater than or equal to -5. Do we understand that? The second problem is the fact that the square root is in the denominator, which means if I actually had -5, I get -5 plus 5, which is 0. So the square root of 0 is fine, but 0 in the denominator is not fine. So that means really, if I had x on root x plus 5, then my answer should be x must be greater than -5. It can't equal to -5. So which means it has to be an open bracket all the way to positive infinity. So anything greater than -5, not including -5. Does that make sense?
Mm-hmm.
Again, a Venn diagram. You probably haven't learned this bit of it, obviously. This is just what's the probability of obtaining A given that you have obtained B. Now there's a formula for this, and you will learn this formula when we do it. But in other words, just saying, yeah, what's the probability of obtaining A out of those who have obtained A and B. So pretty much you're just going to go 10 over 10 plus 6 plus 12, which is easy. It's not, you don't add the 9, but anyways, we don't need to do that. Question. How many unique solutions? How many unique solutions does this equation have for 0 to 2 pi? Well, you'll just solve it, wouldn't you? You're just going to go, okay, if I had this, it's already factorized, thank you very much. So you're just going to write sine x equals 0. And then the other one would be cos x plus 1 equals 0. You'll start solving. So this one here, your first answer is 0. Then you do your all stations to central. What's my next answer?
180.
And then what's my next answer?
360.
Yeah, see, remember that from last week? I said you can just learn to add and subtract more 360s. So if you knew you had 0 as an answer, you know you can add 360s, not a problem. And guess what? It gives you in that domain, so that's your 3 answers there. This one here, cos x equals -1. But we do it like this, x hat equals inverse cos of +1. So inverse cos of +1 gets me 0.
Yep.
Then you ask yourself, where is cos negative? You would have said in S and T, which means x equals 180 only is the answer for that one. But that means how many unique solutions do you have? We only have 3 unique solutions, right? That's a repetition of 180 and 180. So you don't need to include that. So there's only technically 3 solutions. 1, 2, 3. All right. How we feel with that?
Good.
Good? Yeah, that's good. Tiana, same thing. You feel good with that?
Yeah.
Yeah, nice. This one here, again, it's up to you. You want to use, it says area of the sector. So you either use the area formula that you get taught this year, which is this, and then I'll write theta equals rads, or you use area of a sector, which is pi r squared times theta on 360. This one here, theta equals degrees. You pick. Me, obviously, I just choose the second one because I'm used to it, I guess. But you could just use half r squared theta as well. It should not make a difference. Okay, so let's read. The circle centered at O has radius 7, arc length is 6. What is the area of this shaded sector? Right, because they gave me arc length, maybe it's easier to use this first one, but I will use the first one for those who want me to do that, and I'll show you the second way as well. So the formula for arc length is L equals r theta. Your arc length is 6, so 6 equals radius 7 theta, so therefore theta equals 6 on 7. And then obviously to find the area, now that you know what that is, A equals half r squared, which is 7 squared. Let's just write it up here. Therefore A equals half times r squared times theta. And the answer shall be 0.5 times 49 times 6 divided by 7, 21. 21. The other answer, the other way, again, same thing. We don't have the theta, so we've got to use the circumference formula. Circumference equals 2 pi r times theta on 360. You know the circumference or the arc length is 6 equals 2 times pi times radius times theta on 360. You don't go and find theta, you just leave it as theta on 360 because that's the same as this guy here. There's no point of subbing the theta in. You might as well just sub in theta on 360. So then from that you get theta on 360 equals 6 on 14 pi. Right, 2 times 7 is 14, and then 6 on 14 pi. Sub that into the original, so therefore area equals pi times radius 7 squared times 6 on 14 pi. And yep, gives you 21. So really very similar math. Maybe this might look harder to you guys, but it's exactly the same, really. And probably better to understand how I've done the substitution there, because, you know, some strong algebra there, I guess, if you know that not to sub in theta, just to leave it as theta on 360, because they're the same. Okay, all good? Otherwise, easy? Any questions?
Nope.
And you can see, as always, you just need to know a little bit about everything, right? I can't show you this anymore. Eden, you're not allowed to say, hey, where's the AAA questions or the AA questions or whatever. There's no such thing. It's just, you got to know a little bit about everything. That's how your prelims work. All right. Of course, naturally, there'll be questions that are harder. There'll be questions that are easier. That's part of the game. But if you know everything and you know what you're meant to be doing, then should be okay. The function is an even function. And the function of g of x is an odd function. Which of the following is a true statement? All right, I think that's tricky, right? That is your A level question that you want. But you would be wrong to just go about it and start it like this. Right? It's not what I would do. What I would do is go, okay, if fx is an even function, well, let me assume it's x squared. Oh, it's an odd function. Let me just assume that's x then. Because x is an odd function, x squared would be an even function. Let me now do what they're asking me to do. So let's do g of f of x and f of g of x and see what happens. So g of f of x, g of f of x. So if I did g of x squared, that into x gives me x squared, which means that becomes even. So g of f of x is even, which means that's wrong, and that's wrong. So now we're tossing up between these two. See how simple it was? But you guys are not thinking like that yet because of the fact that you haven't exposed yourself to exam questions. As you keep going with the exam style questions and you start exposing, you'll start thinking the way obviously any top student starts to think, which is like this. They look at a question that looks different to them and they just start thinking, okay, well, let me just go back to basics. F of g of x is sub in g of x, so sub in that into that. Well, x into x squared is still x squared, which means f of g of x is even. So we can definitely say the answer is C and not D. I mean, you can check with anything. If I chose this was x cubed, and if I had done f of x cubed, that would be x cubed squared, which is 3 times 2, x is 6, even. All good? Of course, because you know the way I attempted it was good. So you got to think like that as well. All right. Sketch a curve that represents a function which is both many to one and odd in the space below. Okay. What do we remember from one to one, one to many? What do we remember?
Many to one is many x values to one y value.
So many x values to one y value. Beautiful. Okay, then let's try to draw it. If you remember it, that's fantastic. Many x's to one y. Many x's to the one y. So you could draw that. I don't know. Say it again.
I was wondering if it could be a cubic.
No, because a cubic is 1 to 1. There's one x value, gets you one y value. One different x value here gets you one. One y x value gets you one y value. One x value gets you one y value. So that's not many to one. Ugh. I'll show you a many to one, just a basic one. A many to one could be that, right? Because there's two different x values, let's say right there and there, that gives you the same y value. There's two different x values that gets you the same y value. So that would be a many to one. I think I'm going to draw it like this. Ugh, that's really bad, but anyways, you guys get the idea. There you go. See? It's many to one, and it's odd. And if you want to remember how you draw odd functions, even functions are this way. Right? That would be even. Flip it about the y-axis. Then you flip it down about the x-axis. That becomes odd. So flip this way would be even. Flip down would be odd. Does that make sense? Or, yeah, does it make sense firstly? That's the answer we're looking for. Many to one and odd. Yes?
Yeah.
Okay. See, you finish this and it's still not perfect. And the only reason why it's not perfect is because of exams. Exams compared to textbooks. So you might have finished the topic, you understand many to one, but do you actually really understand it and know how to apply it? That's a whole different thing which only comes through exams. Question 12, solve this one. That's easy. Nothing really fancy there. Just 2x minus 3 equals 5. 2x minus 3 equals minus 5. 5 plus 3, 8. 4 minus 5 plus 3 is minus 2. That was easy. There shouldn't be any problems there. Yes.
So for the absolute value of equations,
Yep.
Do you just make the answer a minus? Like have
Yeah,
the
pretty
two
much.
equations, just answer changes. Okay.
Yep. If it was an inequality, we still make it equal to, and then all we have to do is do a testing. We test 0, whatever it is. Yeah?
Yeah.
You guys do inequalities? Actually, do we do that in 2 unit? I don't know. Or is that extension 1? I don't even remember. Did you do absolute value inequalities?
I don't think so.
I think we covered it for a short amount of time.
Yeah. I think the inequality bit is extension 1. I thought so. I think. But anyways, as you guys revise, you'll know if it's in there or not. But I don't think so. I think it's in extension 1. Find the points of intersection. All right, what do we do? Of y equals 3x and y equals x squared. How do we find the point of intersection of these two things?
Simultaneous equations.
Yes. Easy. I'm not going to do it. I feel like you guys should be able to do it. I'm just going to tell you the first line, which is 3x minus 6 equals x squared minus 2x minus 2, because the y values are the same. So just do that. Bring everything to one side, start solving. So basic equation skills. And then if we've got time, I'll come back and finish it off. Sounds complicated, doesn't it, already? The pH value of a solution is given by the formula. pH equals negative log 10 of H plus with big square brackets, where H positive is the concentration of hydrogen ions in moles per liter. What is this? I've never done this topic. Find the pH value of a solution in the chemistry lab whose label indicates its concentration of hydrogen ions is 2.5 times 10 to the power negative 4 moles per liter. Give your answer to one decimal place. What do I do? Or what am I finding? What letter am I finding? Or what letter is this? One or the other.
pH.
Am I finding pH or is this one pH? You want you can read the question again. Read A again. Sounds like you guys are over reading it, which is why I'm telling you to read it. So just relax when you see a question that's like this and looks weird and whatever. Don't worry, it doesn't mean nothing. There's your pH equals log, negative log. Find the pH. Obviously you need to find H. H is this. Right? Moles per liter, H. That's it. So the pH equals negative log 2.5 times 10, negative 4, subbase 10, which equals negative ln 2.5 times 10, negative 4 on log 10. That was easy. Simple substitution. Negative log 2.5 times 10, negative 4 on log 10. And you shall get 3.6 to 1 decimal place. Everybody got that? No? You didn't get that?
Yeah,
You did or you didn't?
I did.
You did? Okay, good. Easy. See? Simple, right? Really simple. Find the concentration of hydrogen. So find the concentration. Find H. Given pH is 2.4. So again, you have an equation. There it is. Let's just do it the way that we've been doing it. Okay, we've got to make H the subject. What's the first thing you would do? Me, I would multiply by log 10.
Yeah.
Now what are you going to do? Again, me, I know I want to get rid of negative eventually and log. To be able to get rid of the negative, I mean, that's not a problem. We can just, bring it over to this side. Voila, that's fixed. But the fact that to get rid of the log, I've got an exponential. But I can't have this negative 2.4 here yet. Right? That's annoying. So what I am going to do is I'm going to bring it up as a power. So it's going to look like this. And then it's easy, right? H equals 10 to the negative 10 to the power of negative 2.4. Plug that into your calculator. It tells you how they want to see it. They want to see it as 8 times 10 to the power of something to 2 sig figs. 1, 2. So the 8 changes the 9, becomes a 4. So that becomes 4.0 times 10 to the power of 1, 2, 3, negative 3. Just remember your scientific notation and significant figures. Talk to me. How do we find that one? Is that all right? Yes? Tiana, Eden,
Yeah.
all good? Okay.
Yeah, good. Yeah.
Anyone else here yet? No. I've forgotten. All good. Differentiate. Differentiate. What do we use? What do we use? One of the rules.
Quotient.
Quotient. UV. When you're going to differentiate the bottom, what must you also use?
Chain.
Done. Let's do it. U dash V minus V dash U all over V squared. Power of 6 because 3 times 2 is 6. All right, look at it again. U dash V minus V dash is, bring the 3 down, keep the bracket, take away 1 from the power, multiply the derivative of the inside. That's V dash, then times by U over V squared. Okay. Any questions? At this stage, what you do, you always look for your common factor. So with 4, and I start with the first number, always, just how I do it, right? 4 and 2, you do take out a 2. Then the next term, x. Is there any x's here by themselves? Yes, they are, x squared. So you'll take out an x. Then you've got this bracket, power of 3. Well, you've got the same bracket, but power of 2. You always choose the smaller one, right? X and x squared, you took out an x. So this bracket cubed, bracket squared, you take out the bracket squared. Then we ask ourselves what's missing, or however you've been factorizing. So from a 2, how are you going to get a 4? You need to have a 2. X. 3x plus 4, 3 plus 4 squared, that's cubed. So that's 3x plus 4. Minus 3 times 3, 2, 2's already there. X, this is x squared, so I'm missing an x. Now that's a power of 2, that's a power of 2, and you are done. See how slowly I did it? So you can't do it faster than that. You've got to do it slowly so you don't miss any terms. Next line, I can tell these two can cross out. That's a 2, that's a 6, that becomes a 4 now. And then the inside we're just going to fix up, and I think we're done. 2 times 3 is 6. 6x take away 9x becomes negative 3x, and that becomes 8. And we're done. Alright, I'll pause there. I'm going to grab a drink of water, and just let me know once I'm back if you've got any questions. Okay. Any questions?
No.
No. Happy?